All right, so we are back looking at some data visualization, and in this video, we're going to be talking about bar plots. Now, we've got three learning objectives here. We want to understand how a bar plot is constructed, uh, understand how to interpret the information displayed in a bar plot, and to also know when it's most appropriate to implement a bar plot. I need to go ahead and turn off my notifications while we're making this video real quick. So, right, a bar plot's a visualization which can be used in a few different ways, but its primary use is to show comparisons among discrete categories. So we actually see in our first bar chart here, we're looking at gross domestic product by country. There are six different countries here, and then there is the dollars, US dollars expressed in trillions for the GDP for United States, Mexico, Canada, UK, France, and Spain. Excuse me. So here we have categorical data, right? We have the United States, Mexico. This is a category, nation. This is non-numerical or non-ordinal in its nature. And we are expressing the same value across those different possible levels or factors of our category, which is nations. So this is a very common use of a bar plot. The other type of use that you'll see is a bar plot being used in a similar way to the way a histogram would be used. If we look at a histogram, in general, histograms are always going to have a frequency on the y-axis. And let me just zoom in, make sure this is large enough for all of you to see. Right, we have a frequency on the y-axis when we're looking at histograms. The difference here is that on a histogram, what we have is always numerical in nature, which is not going to be the case with bar plots. It's also continuous, right? So this is sort of 82 to 83, 83 to 84, 84 to 85, etc., etc. We'll talk a lot more about histograms. It's one of the most common types of plots you'll use as a statistician, as a data scientist. We'll talk about that a little bit later. But when we're talking about a bar plot, right, we can have a numerical category or numerical data on our x-axis. Like here, we're talking about numbers of cylinders in an automobile. But here, what you're more likely to see is instead of continuous data on that axis is to have discrete points, right? Number of cylinders, 4, 6, and 8 are what you'll commonly see in automobiles. There are some 5-cylinder cars out there, but there are certainly not any 3.2 cylinder cars or any 5.7 cylinder cars, right? There are discrete possible outcomes as to the number of cylinders in automobiles, and that would inform you to maybe use a bar chart instead of a histogram, although in reality, those are sometimes used interchangeably, especially when you're dealing with a bar chart that might talk about frequency. This looks like a data set that had, let me see, it looks like I got 11 plus 7, that's 18, and 14. So this is a data set that had 32 cars. Looks like 11 of those cars had 4 cylinders. 7 of those cars, I draw a sort of imaginary line over here, 7 of those cars had 6 cylinders, and 14 of those cars had 8 cylinders, right? So when we're looking at how we can actually interpret a bar plot, that's more or less what we do is you find your level or your factor of your categorical or your discrete data on the x-axis, right? This denotes the number of cylinders. We say, oh, how many in our data set of 32 cars, how many of those had 4 cylinders, right? And we just fill up a bar to that height. You will sometimes see bar plots as like a lollipop chart. So if we say lollipop chart, right? If I look at this is more or less, and we're looking over here on the right side of my screen, this is, more or less doing the exact same job that a bar chart does, right? And this sort of lollipop chart has become a little bit more popular recently. I think it can be really visually appealing, but the way it works is the same exact way as a bar chart. right? Where you have some discrete level or factor of a category, and then either a frequency or some sort of measurement on the left hand side, right? So we can see one that's measuring an actual statistic, in this case, gross domestic product, but this could be average height, median wealth, lowest, Q1 of income, if maybe we were looking at the poverty levels, right? And we wanted to see, what is the lowest quarter of income for each one of these countries, right? And, is someone who is quote unquote poor in one country, how much better or worse off might they be in comparison to some other country, right? So we can measure sort of statistics or things here on the y-axis, but you'll often see frequency where you have a limited data set. There are two common variations of bar plots that you should get used to seeing. The first is a stacked bar chart. I think it's pretty intuitive to be able to read this, right? We can see that in the month of March, there was a revenue for whatever this company was. This is just totally fake data that I made up. But we can see March, the total revenue looked to be about $11 million. But we can also see, hey, about 5 million of that came from this north region. It looks like maybe 4 million came from the west region, and then the east region had the last 2 million, right? Those are just estimates from these bars that I'm looking at, right? But I can see for a given month, I can see a total revenue as well as a breakdown of that revenue by some other sort of subgroup. And these stacked bar charts, so long as you only have maybe 2, 3, or 4 subgroups like east, west, and north here for our different regions of this imaginary company and their revenue, it's really readable. But if you imagine if I had like east, west, north, south, central, Canada, Europe, right? If I start to have like 7 layers in this bar chart, that's not going to be particularly informative to me, right? It's going to be a little bit too busy, sort of hard to interpret, right? But when you do have 2 or 3 subgroups, sometimes doing this stacked sort of bar chart can be really helpful, right? To look at both the aggregate, this sort of total amount, as well as a breakdown per region in this case. And then the second and the last sort of bar chart variant that we're going to talk about is a side-by-side bar chart. Again, this is largely doing what the last bar chart does. It expresses the exact same information. It just does so a little bit differently, right? As we mentioned, we had that east with 2 million, that west with 4 million, and that north with 5 million. We got that same information out of the last plot, just displayed a little differently. There are pros and cons to this. It's more difficult for me to sort of see the total amount, right? I can sort of judge the total area amongst the 3 bars, but if you look like a month like June, for example, it's sort of difficult to guesstimate exactly what that total is. So that's the drawback to using a side-by-side bar chart or bar plot. But if we actually look at these bar plots and if we just want to make a comparison month to month going region by region, right, it's a lot easier for me to see, east in March was 2 million, east in April was 9 million, east in May was 3 million, east in June was 12 million, and east in July looks like it was 9 million, right? This is a lot easier for me to make a comparison east to east from month to month, but I sort of lose out on the bigger picture of what the total revenue was for each month. It's just not quite as intuitive. So depending on the information that you're trying to display to your user, right, one of these charts is likely going to be preferable towards the other. So that's a quick breakdown on bar plots. We're not going to talk about plotting these now, but we will later on, actually after you've done the interview, as you're preparing for the immersive during DSI pre-course. But really appreciate your time. In the next video, we're going to talk about pie charts, and I look forward to seeing you over there.